Part of the National Center for Nuclear Research, the Maria Reactor is the only nuclear facility currently operating in Poland. The reactor, located at the Świerk Nuclear Center near Warsaw, is a source of neutrons used for the production of radionuclides, modification of materials, and scientific research. Radionuclides produced in the Maria Reactor are used primarily in nuclear medicine. The Pol-Atom Radioisotope Center, which is part of NCBJ, produces radiopharmaceuticals delivered to hospitals in 80 countries on 6 continents. In particular, Maria's production caters for the main part of the world demand for iodine-131 used in thyroid therapy. Since March 2010, in cooperation with a foreign partner, the reactor staff have implemented technology for molybdenum production by irradiation of uranium targets. Irradiated targets prepared in Maria are the basis for production of molybdenum technetium generators containing molybdenum-99. As a result of molybdenum decay, technetium-99M is created, which is a basic component used in most cancer diagnosis procedures. A single reactor workweek provides for the treatment of 100,000 patients worldwide. Maria is a high-flux, channel-type pool reactor with beryllium moderator and graphite reflector. The first reactor startup was at the end of 1974. During over 40 years of operation, primary installations such as the cooling circuit, radiological protection system, and beryllium matrix have been upgraded. In 2012-2014, the reactor core was converted from highly enriched fuel to low enriched fuel. The highly enriched fuel was exported to Russia. The fuel for the Maria reactor is uranium silicide or uranium oxide, placed in over 1 meter-long fuel elements. During a typical several-day cycle of reactor operation, about 25 fuel elements are used, each with its own water cooling system. The vertical channels for irradiation of radionuclides are in the vicinity of the fuel elements. Cartridges for irradiation of minerals are placed next to the core. There are 6 horizontal channels leading neutrons from the core out to the experimental hole. Reactor employees are protected by a 7-meter-thick layer of water above the core and the thick concrete walls of the reactor pool. In 1 year, Maria uses approximately 20 fuel elements. During the next few years, spent fuel elements are stored in a dedicated pool next to the reactor. Materials for irradiation are placed in special sealed containers. During one cycle, more than 100 containers can be positioned simultaneously in the neutron flux. The irradiated materials are usually highly radioactive. They are carried underwater to hot chambers where, behind the lead glass protection barrier almost 1 meter thick, they can be repacked into transport containers and shipped to recipients. The reactor is also used for conducting physical studies, employing the horizontal channels, and for student training. Researchers from NCBJ are involved in collaborations with similar laboratories around the world. For example, the result of work carried out in Świerk will be used to launch the JHR research reactor in Kadarash. The Maria Reactor experimental hall is currently being reconstructed. Once completed, it will be equipped with advanced research instruments transferred from the Helmholtz-Zentrum Berlin. Right now, with the help of a horizontal channel and a neutron converter, a new test bed for boron-neutron therapy is being built at the Maria reactor. Completion of this investment will provide scientists from Świerk with the opportunity to carry out experiments and research in radiobiology, radiation dosimetry, irradiation of biological materials, as well as training of oncologists and other medical personnel. Maria plays an important role in the process of social education. Every year, about 7,000 students and other guests visit the reactor during educational tours. Visits to the reactor and other activities are organized by our specialized educational center at the institute. At the moment, despite its age, Maria is one of the most modern nuclear reactors in Europe. The reactor is licensed to operate until the end of March 2025. However, current technical assessments suggest that the next upgrade will enable safe operation of the installation up to 2050.